Hello guys, thank you so much for being with me in another machine learning tutorial video. In the previous video we talked briefly about the relation of multivariate Gaussian distribution function. I hope you read about it if you are interested in this relationship. X minus mu is 1 in n vector, and its transment is an n in 1 matrix. As a result, the output of this relationship is finally a number. This number is the probability. In order to have this distribution, we must have mu and the covariance matrix. Check out some different examples here in this covariance matrix. 1 in the first row means in the horizontal direction. For example, x1, and 1 in the second row, for example, in the vertical direction, for example, x2. We have considered the correlation to be 0. We have only changed the scatters. You can see that as the dispersion gets smaller, the graph gets sharper. This is dispersion standard deviation. I mean, in two directions is not necessarily equal, and if they are not equal, we will have an oval shape. These correlations can be negative, that is, as x1 increases, x2 decreases. In this case, the rotation direction of the photo will be different. I want you to understand the concept of these two matrices well. Centers may also be different. You can see the role of this average vector in these figures actually. Now we want to solve the problem with multivariate Gaussian distribution function. Again, we need to estimate the parameters. The average, the mean has not changed. The xi means of an n vector is in 1. So its output is a vector in n. So the result will be an n by n matrix. This covariance matrix can be written more simply. You can see in the Python files that the implementation is very simple. Like the theory, that the first step is to estimate the parameters with the x vector without any other information. Now, according to this, we can calculate the probability of occurrence of that data, and if it is less than epsilon, we can predict the data as outlier, and otherwise it is normal. In the case where we did not consider the correlation, it was actually a special case of the anomaly detection problem, considering the correlation where the covariance matrix is diagonal. Here is a comparison between the basic model and the multivariate Gaussian distribution. There are implementations in Python files. I emphasize again that you must pay attention to the files. Practice, practice, and practice in the scope of programming and also machine learning to become expert, and do not satisfied with such theory and concepts because these are not enough. Practice, practice, and practice. So I again highly emphasize that please pay enough and significant attention to the Python files which I've provided for you. And also I highly recommend you not to miss the upcoming lecture. Actually, the next lecture will be the last one in this tutorial, and it will be about the recommender systems, which is a very practical concept in machine learning. If you want to be a good machine learning engineer, and if you want to find a very good position in the area of machine learning, you will very much benefit from the concepts of recommender systems. So I highly recommend you stay tuned and benefit from the last video, which will be the next video. Have a nice time.